The great white shark swims alone. But for less formidable animals, it pays to be a face in the crowd. Animals have joined forces again and again throughout the 4 billion-year history of life. In the battle for survival, working together has proved to be a winning strategy. The power of teamwork is one of evolution's greatest triumphs. Shallow tropical sea, one of the most diverse and colorful habitats on Earth. But its beauty conceals a harsh reality. A battle for survival has raged throughout life's 4 billion-year history. That fight continues today, here as much as everywhere on the planet. Only the biggest dare to cruise alone. The reef can provide shelter for many small fish, but others find safety through one of evolution's major advances: living in groups. Traveling in company means never facing predators alone. The shimmering dances of shoals distract killers from focusing on one target. Silversides find safety in a crowd, hiding behind each other. Fish out of step risk being picked off as they lag behind. The same dance for life has evolved many times. In aerial ballet, starlings strive to avoid a falcon's killer grasp. There's safety in synchrony, a spectacular defense widely deployed. Among reindeer, the deadly dance is with wolves, but the steps for survival are the same. Migrating wildebeest are safer in convoy. A crocodile can only kill one at a time. Each animal is more likely to save its own skin by simply following the herd. But in one of life's greatest breakthroughs, true teamwork has evolved. This social revolution is based not just on herding, but on cooperation and self-sacrifice. Meerkats live in teams, whose individuals don't just help themselves, they help each other. Rising from their safe den, they are hungry after the night. But it's dangerous out here. The main threat comes from above. The eagle does not notice them. Sensing the coast is clear, the meerkats venture into the open to dig for insects. In teams, individuals play different roles, and perched high in a bush, a lookout watches over the foragers. Another adult stays back at the den. Not all the group will get a chance to eat today. As today's babysitter, this team player is looking after the young of the only breeding female in the group, keeping them safe from danger. The guard's warning alerts the others. Meerkat teamwork, like most cooperation between animals, is based on family. In nature, blood is thicker than water, and most of this team are helping younger relatives. Helping of family seems to be the origin of all animal societies. Mammals don't have a monopoly on such helping. Some of the most selfless acts occur between the smallest creatures, living in families of vast size. One of the most fearsome sights in Africa. The biggest family outing on Earth. Millions of driver ants, all siblings. They're on a mission to kill. And kill they do. Almost anything their flowing horde washes over. Single ants aren't much of a threat. But working as a team, they overpower prey many times their own size. Unable to escape, the victims are dismembered and carried back to a hungry brood. Parties of workers pull together while larger soldiers stand guard. Not all animals caught in the flood are entirely defenseless. As the attack starts, this banana slug exudes copious quantities of slime. Undeterred, the ants step up the attack, risking death by slime for the good of their family. For the slug, resistance is futile. All out of slime, it is sliced into steaks. Incredibly, other ants rush in to rescue their entrapped kin. Crumbs of earth are used to sponge up the slime. They now pull away what's left to release gummed-up siblings. Helping family seems so natural, it's easy to take it for granted. But there is a mystery here. Why should relatives help each other so selflessly? Clues can be found within the supremely coordinated body of any living creature. Bodies are billions of cells, eye cells, brain cells, and muscle cells, all working together. These cells have one thing in common: their genes. At conception, a single cell splits and an embryo forms. At each split, a complete body construction manual in chemical code is copied into the new cells. The instructions are the genes. As each cell is genetically identical, all are perfectly related. In other words, they're clones. The cell clones soon number in the millions. Depending on their position in the embryo, the cells read different chapters of their identical instruction books and form the various parts of a body: heads, tails, and vital organs. The miracle that is a living body is a mass of identically related cells, clones, working together and steered by the genes they share. This bonding between perfect relatives can also operate on a much larger scale. Like any multi-celled animal, a seal consists of cloned cells. But on the rocks below are teams of cloned individuals that work together as if in a single body. Each of these blobs of jelly is a clone belonging to one of two opposing armies. The gap between them, a battlefront, frozen by the onset of low tide. As the tide rises, they reveal themselves as sea anemones. There are two feuding families here, a pink-tip team and a green team. They face off over no man's land. Within each family, the members are genetically identical. They are natural clones. The anemones are formed like cells in a body by splitting from one original. Amazingly, the resulting army of clones behaves as if it were one huge animal. Like a cell in an embryo, each anemone has a job. Those in the middle of the body are the reproducers. And like a protective outer skin, warrior anemones form a front line, heavily armed with stinging clubs. The warriors are also an attack force. Driven to reproduce, both clone teams on this rock are trying to expand. This is clone war. Cloned anemones sharing all genes will die for the team, as will cells in a single body. Skin cells of a battling elephant seal die in their millions. But for the winning body, the payoff is reproduction. Identical genes to those carried by the cells killed now have a future. But when two animals come together to reproduce, genes must share their future with others. The next generation are not clones. This baby carries a mix of genes from both its parents. And families, unlike clone teams, are full of tension, as individuals juggle sacrifices made for their family with self-interest. Caring for the new generation is the basis of all animal societies. This family is a tight social group of a female cheetah and her closest relatives, her cubs. A mother protects her young. Ancient pressures have molded this instinct. Predators such as lions kill young cheetahs. At risk to herself, the mother cheetah distracts the lion long enough for her cubs to escape. The cheetah's protective urge is as much a product of evolution as is her sinuous body. But she must balance caring for cubs with self-preservation. In the long run, cheetah mothers rear more young by giving all the care they can, but without dying in the process. The cheetah's maternal instincts not only cause her to bring them meat, but as a mammal, she has evolved another trick: milk. By suckling them, she is their lifeline. Her maternal care has been honed by natural selection, giving her genes a future. With their mother working hard to feed and protect them, these babies themselves stand a good chance of surviving to breed. But they also carry the genes of another parent. So where is he? This is their father. Because the mother can rear the young alone, he is free to sire more babies with other females. Evolution has shaped virtually all male mammals to behave this way, since they can pass on genes without caring for babies. But there are rare exceptions. A family of 4 TT monkeys, including mom, a baby, and dad. Their lives and their relationships are shaped by their home, perilously high in the forests of South America. Here, Dad sticks around, and he's left carrying the baby. Mom has lost most caring instincts. Her role is limited to providing milk. As soon as she's finished suckling, the baby is passed back to Dad. To survive up here, babies must be carried everywhere, but Mom can't do it. Making milk takes up so much of the energy she gets from her food, she has none left to carry babies. TT males cannot abandon their families as most male mammals do, because their babies would fall, die, and their genes would be lost. Due to the demands of treetop life, TT males have evolved family bonds. Such two-parent families are very rare in mammals, but not everywhere in the animal kingdom. For most birds, parenting is also a team effort. But if food supply is unpredictable, there can be friction in the family. Masked booby pairs display a tender and seemingly affectionate bond. This nesting colony is on the Galapagos Islands. Females lay 2 eggs. Many fail to hatch, but if both do, there's trouble ahead. Emerging a few days after the other, the younger chick is at a dangerous disadvantage. Their parents struggle to catch enough fish for both of them. And even when they've done well, there are further problems. Frigate birds, masters of mugging, target boobies that have a hard-won load of fish inside them. With the fish stolen, both chicks will go hungry today. Shortage of food has turned booby family life into a battleground. Older chicks always force the smaller chick from the safety of the nest. The parent does nothing to stop it. The exposed chick attracts the wrong kind of attention. A hungry frigate. Life in a booby family seems harsh, but with its competitor removed, the older chick may now survive. But some bird siblings facing different pressures don't become enemies, they become allies. Southern ground hornbills, an extended family. The parents, 2 adult sons, and last year's chick. She's the only daughter. Her sisters left to set up their own families. Male offspring never leave home, but they don't sit around idle. They help out with the family business. It's safely housed in the middle of this baobab tree. This year's chick. Working to feed it are all the adults, including the grown-up sons. This male is feeding a chick that's not his own, but it isn't wasted effort. As its brother, he shares as many genes with the chick as he would with his own offspring. But why does this family cooperate when others, like the boobies, fight? Teamwork helps to keep this huge and seemingly insatiable chick well stuffed. More importantly, a big territory is needed to supply so much food. Good territories containing a nesting tree are very hard to find. A son's best option is to delay breeding until he inherits the family territory. Until then, he helps rear siblings which carry copies of his genes. This delayed inheritance of land bonds hornbills into an extended family team. In the same African bushland, grazing animals such as impala are constantly threatened by a more complex extended family, a family of predators. Rudely awakened by scrapping pups, an African wild dog pack begins a session of ritual bonding. In wild dog society, males and females from 2 different families form a new pack. Leaving the pups behind, the adults go hunting. Pack living is deadly efficient. The pups share genes with both sides of the family. Their parents are the oldest male and the oldest female. All the dogs pull together to feed them, and they receive meat from many mouths. Sometimes a pair not in a pack manages to raise a few pups, but this is very unusual. Wild dogs have enemies, including hyenas. In a pack, there are more eyes and ears alert to danger. In small families, the pups are usually killed. These puppies are safe, at least for the moment, fed and protected by their complex family team. Other extended families have evolved into much larger teams. In the deserts of southern Africa, after brief rains, sand is damp and workable, and one industrious family piles 2.5 tons of it into thousands of castles. The builders are secretive, subterranean, and weird. This strange rodent is a Damaraland mole rat. It lives in a vast network of tunnels, but not alone. Damaralands live in colonies, large families of up to 40 individuals, and for a reason. They chomp sand as a team, furry drill bits randomly prospecting for widely spaced prizes. A strike. Hundreds of bulbs and tubers packed with nutrients and water are stored away. Only by working together can they keep this chamber stocked and fuel the colony through the barren dry season. Father and mother, the only breeding pair. Mom and the youngest siblings eat from the store all the year round. Back at the cutting edge, the work goes on. The team must make the most of the short window of time before the sand becomes too dry to dig. Juveniles going off duty play fight on the way to the communal sleeping chamber. The exhausting business of finding food in this dry dirt has forced mole rats to work together. Each of these mounds of dry dirt is the castle of one huge animal. An animal with a body made up of 1 million separate working parts. These working parts are brothers and sisters. They are termites, living and working together so harmoniously that the whole colony acts like one vast super-animal. These are termite workers, soft-bodied and blind, making the most of a rare humid morning to extend their home. Acting like cells of the superanimal, termites have evolved tools for different tasks. Most are workers, or, like this one, heavily armed soldiers. In chambers deep in the mound, workers cultivate edible fungus. These chambers form the superanimal's stomach. But all this life creates carbon dioxide. If it were to build up, the superanimal would suffocate. The shape of the mound itself prevents this. The high chimneys reach into the swirling wind, allowing the colony to breathe. Tubes and chambers are refreshed with oxygen. In effect, the superanimal has evolved a gigantic lung. In the very heart of the mound lies the superanimal's reproductive organ. A chamber containing the only fertile female in the colony. The living egg production line that is the termite queen. All the sterile attendant workers, both male and female, share her genes, as do the million others in this mound. The queen produces an egg every 3 or 4 seconds throughout her life of some 30 years. The baby termites are raised together in vast nurseries. These babies are all sterile. Their life work will be to prepare others for a momentous night in the future. Beneath a heavy night sky, the family waits for the perfect moment. Just once every year, rain triggers magic from this muddy mound. These virgin kings and queens are the colony's glittering legacy, winged messengers delivering copies of the superanimal's genes into the future. Termites are hugely successful, but are themselves threatened by an even more powerful superanimal, the ant. This is a scout for a marauding army. Finding a suitable target, it heads for home, laying a chemical trail as it goes. Other ants will soon follow this back, in numbers. The termites are oblivious to the danger. The scouts' relatives are killers, but picky. They target only termites. Termite warriors, specialized for biting, defend the front line, but they're no match for the ant's jaws and deadly sting. Suddenly, the raid is over. With swift efficiency, the ants gather mouthfuls of termites and march home. The world is ruled by family teams. Ants alone outnumber humans 1,000,000 to 1. And for a very select number of species, cooperation can go beyond family ties. Such alliances rely on trust. Every night, 1/3 of a million bats pour from this Trinidadian cave to feed. Among them, the greater spear-nosed bat. It has recently been shown to live in a society based on trust. One bat finds an open nut case, a bat jackpot. Willing to share, she calls loudly. But the bats that respond are not close relatives. They are females that banded together when they left their parents. Effectively, they're friends. Each bat here is a working mother. She can take her time because, remarkably, back at the cave, they operate a babysitting club. At first sight, this cave seems to be total mayhem, a disorderly squeaking rabble. But a closer look reveals the method in this battiness. In each roof dimple, a creche of babies, but not home alone. They have babysitters. Astonishingly, though closely related to just 1 or 2 of the babies, they care for all, listening for a distress call from any baby in the group. Flying lessons are a risky pastime. Predators wait below. It must get off the cave floor, and quickly, before the possum notices. And in foul pools lurk other dangers. Out of immediate risk, it starts to shriek. If left here, it will die of cold. Alerted by the cries, a babysitter swoops to the rescue, even though this is not its own infant. A second babysitter arrives. If the baby's to survive, it must get a firm grip. Almost there. This rescue system works because these bats have the brain power to get to know each other as friends and to trust each other to be good babysitters. This sort of cooperation is very, very rare. Spear-nosed bats are minor league in this trusting game compared to one other species. A species found throughout the world, spreading to the remotest corners. It can even cope with the extremes of an Arctic winter, surviving here only through trusting cooperation. Humans. Several cultures have blossomed in the snow and ice through the power of human societies. In our natural state, we're naked and defenseless. All the other animals here have bodies shaped by evolution to fight against the Arctic cold. Reindeer are born with natural survival equipment. Their hairy noses warm the air they breathe. And their hooves have become splayed snowshoes. Confronted by an old adversary, they rely on safety in numbers. Warm in their thick coats, family teams of wolves hunt across these Arctic wastes.
But neither reindeer herds nor wolf families dominate this habitat as they once did. Wolves have been driven away by a newcomer, the team player with the added dimension.
Humans have evolved huge brains, giving us uniquely powerful social skills based on trusting cooperation. Although we have few natural defenses, our societies dominate much of the Earth. The story of human evolution is not of people battling the elements alone. We are able to share solutions to survival problems with other humans from a much larger society. Every winter, the Sami people of Arctic Europe corral their reindeer, helped by their families. And by others from a wide social circle, friends that they will help in turn. Teaching and sharing knowledge is just part of the intricate exchange that makes us human. Our cooperation goes beyond families and a few close friends. Our huge brains allow us to keep a mental record of favors, which, one way or another, we trust will be returned. We're no angels. Our brains are packed with potential for conflict and cheating. But we have also evolved a uniquely powerful potential for cooperation through trust. Wherever stable human societies have been created, that trusting potential has been nurtured. Trust is the currency of humanity. Genes, life's blueprints, have been carried on a ceaseless journey by countless generations for 4 billion years. That journey continues today as survivors of life's ancient struggle pass on successful genes. From humble beginnings, animal teams have risen to dominate our planet. winning teams now share in the great triumph of life.
To learn more about what you've seen on this nature